Nike makes nice cleats.
I like
New Balance, baseball and softball cleats are like top one. Alright.
New Balance?
New Balance,
Yeah,
yeah.
I like them. They're really nice.
Alright,
They make good
Guys,
cleats. Nike,
hey,
they're not bad.
Jared, shh. You can argue about cleats later. Alright, so, yesterday we talked about using law of sines to solve triangles, right? The non-right triangles. Today we're going to learn law of cosines, because not always we'll be able to use law of sines. Right? Think about this situation. If you're given this triangle, can you solve that using law of sines?
No.
Why not?
Because you just have a side and an angle measure.
We don't, so we just have sides and angle measures.
We don't really have enough information.
We don't have enough information because we need what?
One more angle.
We need at least a side, and an angle that correspond with each other, right? We don't have that. So in a case like this, when we have something where it's two sides and an angle in between them, or we're given all three sides and no angles, we're going to use what we call the law of cosines to solve it. Alright, we're going to learn law of cosines today. So once you do law of cosines once, you get that one piece of information you need, you go back to law of sines. Right? Law of sines is the easier one. Law of cosines is a little bit more difficult, a little trickier. So once you do law of cosines once, you get all the information you need for law of sines, you can go back to it. Alright? Law of cosines. Law of cosines says a squared equals b squared plus c squared minus 2bc times cosine of a. A lot of stuff there, right? A lot of stuff. Now, all three of these equations here are the same thing. They're just written in different ways if you're solving for side A, B, or C. They're the same thing though. Alright? We're going to use the equations on the left when we're looking for side lengths. They're the easier way to solve for a side length. If we're looking for an angle measure, we're going to use these equations over here. All it is, it's the same equation, but it's solved for cosine of A. We did all the algebra for you. Instead of making you solve for the angle measure in this, and doing all the algebra after you plug everything in, we did it for you already. Cosine of A equals b squared plus c squared minus a squared over 2bc.
Thank you.
Alright, yes, you need to know the equations.
Oh, wait, so why are there two different versions?
Because if we're solving for a side length, we're going to use this one. If we're solving for an angle measure, we're going to use this one.
Okay.
It's the same equation, just written differently. Alright? So, it looks like a lot of mumbo jumbo. Right? You'll get used to it as we go along. Think of it as you're solving for a side length. I want to take the other two side lengths squared, add them together. Then I'm going to subtract off 2 times those other side lengths times the cosine of the angle that corresponds to the side I want to find. Right? You'll figure out a way to remember it. I'm sure of it. You guys are pretty smart. Right? The more you practice it, the better you'll get at it. The 2 times we're going to use this most of the time. So the 2 things when we're going to use law of cosines the most is when we're given a triangle that we only have the 3 sides for. We need to find the 3 angles. Or if we're given a triangle, we're given 2 sides and the angle in between them. Right? So those are the 2 kind of circumstances we're going to use law of cosines for. Any questions? Like I said, once you use law of cosines once, you go back to using law of sines. Alright, let's try a problem. The first one, I'm given 2 sides and the angle in between them. I can't use law of sines. I don't have enough information to do that. So what I need to do is I need to solve for one more piece so I can use law of sines. In this case, I'm going to solve for the 3rd side length. I'm going to solve for this side over here. Now, it says xwy. The equation I was given was an ABC.
Just change it.
Just change it, right?
Does it matter?
Change the equation if you want, or change these to A, B, and C.
Does it
Now,
matter
when you,
if, like WBA and like
it doesn't matter,
Okay.
right? You can make them whatever you want. But when you go to write your answer, you still have to use those original letters. So don't just like scribble over them so you can't see them. So when I go to write this, I'm going to write side X. Side X is equal to something. I'm not going to write side A. I'm still going to use those original letters, those original variables. But I can change to A, B, and C for right now, so I can use my law of cosines. So I'm going to solve for side A. This will be side B, that's side C. I know. I'm going to solve for A. I'm going to do A squared equals. I'm going to take the other 2 sides and square them. B squared plus C squared. Minus 2 times the other 2 sides. So 2 times B times C times the cosine of the angle across from the side I want, or the cosine of angle A. Right? And all I'm going to do, I know side B, I know side C, and I know angle A. So I'm going to take 1, 2, 3 things, plug them into my formula. A squared equals 3 squared plus 5 squared minus 2 times 3 times 5 times cosine of 32 degrees. You all follow me there? Yes? No?
Yes.
Awesome. So, if you're really good at the calculator, go ahead and plug all that in. If you're not so good at the calculator, take it step by step. Right? Write it out as a squared equals 9 plus 25 is 34 minus 30 times cosine 32. If you do take it step by step, you get it to that point, do not do 34 minus 30 first. Do not do 34 minus 30. Why can't I do that first?
Because it's 30 times cosine.
It's 30 times the cosine. It's order of operations, right? Multiplication comes before subtraction. We have to do the multiplication before we can subtract. Alright? So be careful. So we can plug this into our calculator. We get a squared equals
8.56.
8.55. Do not round it yet. We're not to our answer yet. 8557115, right? We're not to our answer yet. Why not?
We need to.
We need to take the square root, right? Because it's equal to a squared right now. So what I need to do is I need to take the square root of both sides. Instead of writing all those numbers out again, I'm just going to write that. You guys, can you follow that?
Mm-hmm.
Yeah? Alright. So then a is approximately now. Now is when we can round. Now we get it equal to a.
2.93.
2.93. Awesome. So a is approximately 2.93, which means actually side x is 2.93. And there are labels there, so maybe put a label on it, I don't know. Just an idea. Centimeters.
That was a very weird size when we looked at the graph.
It is. Not everything's drawn to scale. Alright, now you can keep using law of cosines if you want. It's a little more work, a little more confusing. Or you can go back to law of sines, because now I have an angle and a side that correspond with each other. So I'm going to find, let's find angle B, or angle W. So, I gotta use this. Alright, I'm going to do law of sines. So sine of 32 over 2.93 equals sine of, I don't want C, I said B, didn't I?
Yes.
Sine of B, or sine of W if you're still using X, I, and W. Sine of B over, side B is 3. Alright? So, cross multiply and solve it. 3 times sine of 32 equals 2.93 times sine of B. How am I going to solve this? I want to solve for B.
You gotta.
Divide by 2.93. Let's start there. So I get 3 times sine of 32 divided by 2.93 equals sine of B. Alright? Last thing I gotta do, I don't want sine of B, I want just B. So I gotta take
Inverse sine.
inverse sine of both sides. So I'm left with B is approximately, now remember, what is B? Are we looking at an angular side length?
Degrees.
It's degrees, it's an angle measure, so I want to the nearest whole degree. So angle B should be
33.
33 degrees. Right, now when we're looking at our original triangle, that'd be angle W. So if I go up here, angle W is equal to 33 degrees.
And then we can just do math.
And then we can just use algebra, right? All 3 angles of the triangle to add up to 180. So 180 minus 33 minus 32 should equal
115.
115 degrees. So, angle Y then is 115 degrees. Alright? Any questions on that?
No.
All you gotta do is use law of cosines once, then go back to law of sines. Alright? Any questions?
Can I get going?
No. Thank you for asking though.
Good question.
No.
Thank you for asking me.
I didn't tell him that.
Can we continue on to the next
Alright,
practice
Next
problem?
problem is that other type of problem where we're given 3 side lengths and no angles. So,
Can't figure that out.
no, we can now that we know law of cosines. But we're going to use that other formula, right? Cosine of A equals B squared plus C squared minus A squared over 2BC. I'm going to use that one to find an angle measure. Right? It's the same thing as this, except I solved it so it's just cosine of A on one side. Alright, you can plug it into this one. You can plug A, B, and C into here if you want and do the algebra yourself. More power to you. Or you can use this one, make it a little bit simpler on yourself. We're good to go. So, once again, we're given W, X, and Y. Well, you can change it to A, B, and C if you want. So, I'm going to go A, B, C. Alright, so this will be side A, that'll be side B, that'll be side C. You can label them however you want. You can solve for whichever angle you want first. I'm going to solve for the top right one. So I'm going to get cosine of angle A equals, I want B squared, so 4.8 squared, plus C squared, so 3.5 squared, minus A squared, so minus 2.8 squared, all over 2 times B times C, so 2 times 4.8 times 3.5. Now, once again, if you are a genius with your calculator,
Thanks.
you can plug it all in, go right ahead. Otherwise, split it up. Do the top part, do the bottom part. Do the top part, I should get 27.45 over my bottom part should come out to 33.6. Right? We got that? And then what do I have to do? I don't want the cosine of A. Ethan, what do I need to do? How do I get A by itself? The inverse, right? The inverse cosine, very good. So take the inverse cosine of both sides. When I do that to this side, inverse cosine and cosine cancel them out with A. And I take the inverse cosine of 27.45 over 33.6. I'm going to do the inverse cosine up here. So, I get A is approximately, because I want an angle measure to the nearest whole degree,
35 degrees.
35 degrees, very good. So, that is actually angle W. So, I go write my answer, I'm going to write it for angle W, 35 degrees. Awesome, very good. Now, you can use law of cosines again if you want.
No.
Or we can go back to law of sines, find another angle. Let's go back to law of sines. So, if I do this, I have angle A and side A, so I need to do those two. Sine of 35 over 2.8 equals, which one do we want to solve for?
Y.
Y, so C. So sine of C over 3.5. Right? And we're just going to cross multiply and solve it. So, 3.5 times sine of 35 equals 2.8 times sine of C. We're just going to divide by 2.8 on both sides. We get 3.5 times sine of 35 over 2.8 equals sine of C. And Noel, what do I need to do?
Get the inverse or
Take the inverse sine, right? Both sides. I'm just gonna write that out so I don't have to write everything again. So take the inverse sine. When I do that, I should get C is approximately
45.8.
45.8. What am I rounding to though?
46.
46, nearest whole degree, right? 46 degrees. So, we said that was angle Y. So 46 degrees, 46 degrees.
Now we just add it up.
Now we can just do the algebra, right? They have to all add up to 180. So, 180 minus 46 minus 35 should equal
99.
99 degrees. So angle X is 99 degrees. Awesome. Any questions? No? You guys are all rock stars with this already?
Can we skip the last one?
Wait, Ryan,
You
go on
can't.
to playing
Can we
first
continue
Yes,
with
he's
the
going to
last
play
one?
first base against lefties this year.
base? Yeah,
Wait,
why
that's
is he not
weird.
playing outfield?
Because
He's
these
old.
three are playing outfield and they're really good at that.
I guess. Well, we should
And
have
Thames struggles
Why
with
does
lefties.
this matter right now?
Alright, we do the last problem, then we can talk more about baseball. Alright, law of cosines. A golfer hits an errant tee shot lands in the rough. A marker in the center of the fairway is 120 yards from the center of the green. So, a marker here is 120 yards from the green. He hit his ball way over here in the rough. So, if he looks at that, he knows it's 120 yards there. He turns 105 degrees to face his ball. He then paces off 40 yards to his ball. He wants to know how far he is from the center of the green. So, I want to find that third side length, right? I want to find this side over here.
Why can't he solve his own problems?
Because he requires us to solve them for
Why
him.
can't you just go to the green and count his pages
Can we
from
just
there?
Because that'd take too long.
Why?
He'd be penalized a stroke for slow play. So,
That's a
So then
that is a thing.
In
Well,
golf,
affect me.
So, I'm going to label them A, B, and C. Right? A, B, and C. I'm going to solve for side A. So remember, A squared equals B squared plus C squared minus 2BC times cosine of angle A. So, plug in what we know. We know angle A, we know side B, we know side C. So A squared equals 40 squared plus 120 squared minus 2 times 40 times 120 times cosine of 105 degrees. Once again, take it step by step, or put it all in your calculator right away. So A squared equals 16,000 minus 9,600 times cosine of 105. Alright, we should all get that when we simplify it. Then, plug that in your calculator. I'll give you a second to do that. We should get A squared equals 18,484.66283. We need to take the square root, because we want A all by itself.
I did not. Oh, wait.
Is that
I
a
forgot.
multiplication sign or a decimal?
Right here,
Yeah.
the decimal. Did we all get that?
No.
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 Are you sure it's not 16,000 or not?
That's what I have right here, 16,000.
Or 1,000?
Oh.
It is 16,000,
Yeah, I.
not 1,600, 16,000, right? 1,600 times whatever 120 squared is. I don't know if
Yeah,
you know
no, I got it.
that. All right, we all get this then.
Yes.
Guys, we all found this?
I'm following you.
All right, so we take the square root of that, we get A is approximately what?
135.96.
135.96 yards.
I didn't want you to.
So it's about 52 degree wedge in.
Sure.
What wedge?
52 degree.
Which one's the wedge?
Oh my god, doesn't matter.
Just be
Yeah,
like,
I mean, yeah.
mystery. I just grab the 9 iron every time. That's
That's a poor decision.